let us solve this question. Here we have two SRP values, one for ferrous to Fe, another one is ferric to ferrous, SRP values for this redox electrode. This is a redox electrode, ferric to ferrous, and another one is metal ion electrode. The two SRP values are given, and the question is, using this data, you need to find out E naught for this cell reaction where ferric is being reduced to Fe. So here what we can just do is, to obtain this equation from these two equations, we need to simply add these two equations. If you add these two equations, you know very well, ferrous gets cancelled out. The overall number of electrons will be 3. So ferric plus 3 electrons gives Fe. You get that. But then the problem is, you cannot add these two values, as these are E naught or E is an intensive property. So intensive properties cannot be added. So what we need to do is change these values to some extensive property. The extensive property we can change is into delta G. So change it to delta G and add the two values. What we need to do is find corresponding delta G naught value for this and delta G naught value for the second equation. Add the two values, you get delta G for this. And then from delta G, again you find out E naught. I'll do it. You can see the options given are 0.33 volts, 1.21 volts, minus 0.33 volts and minus 0.04 volts. These are the four options given. Let's try to find out the correct answer. Solution. Write the two equations. Fe2 plus aqueous plus 2 electrons, it gives Fe. It's better to write equilibrium reversible arrows, solid, and the E naught value given is minus 0.44 volts. So here only I'll write corresponding delta G naught value. Delta G naught, we have a relationship delta G equals to, the important equation we need to remember is delta G naught equals to minus NFE naught, where N stands for number of electrons involved in the cell reaction, F is Faraday, that is 96,500 coulombs, E naught is standard reduction potential. So delta G naught comes to minus N for this reaction is 2, number of electrons involved is 2. So take it as 2, then F, then you need E value, E is minus 0.44. That comes to delta G naught comes to 0.88 F. Okay. In a similar manner, you write this equation, Fe3 plus aqueous plus electron, reversible arrows, you have Fe2 plus aqueous. E naught is 0.77 volts. Now corresponding delta G naught value, I'll call it delta G naught 2. This is minus, N is 1 because 1 electron is involved in the cell reaction, and then you have F, then the value 0.77 volts. Now add the two equations. Let us add them. When you add them, this gets cancelled out. Now, what is the overall reaction? Ferric plus number of electrons are 3, reversible arrows, and on the other side we have Fe solid. And corresponding delta G naught is the sum of these two. So this comes to plus 0.88 and this comes to minus 0.77 F. So it comes to 0.11 F. Now this has to be once again changed to E naught value for this particular equation. This delta G naught corresponds to this equation. Using this delta G naught, we need to find out E naught for this equation. So again use the formula, delta G naught equals to minus NFE naught. So E naught will be delta G naught by NF. Now put this value. So E naught equals to 0.11 F by minus here by number of electrons involved are 3 F. This F gets cancelled and you get E naught equals to approximately 0.04 volts, minus sign here. So the correct answer is fourth option. I'll once again tell you what we have. The data is E naughts are given. We have changed it to delta G naught because E naught is an intensive property, delta G naught is an extensive property. Extensive property means extensive properties are additive. When equations are added, delta G naughts also can be added. If an equation is multiplied with some number, you can multiply delta G naught with the same number. So that is the meaning of extensive property. So we have changed E naught, an intensive property, into delta G naught, which is an extensive property, and we could calculate E naught for the given equation, that is ferric to Fe.